All right, today we are going to decode one of the most powerful ideas in all of chemistry. We're going to figure out how scientists can look at a single molecule and basically predict its personality. How it's going to behave, who it'll interact with, and what it can do. So, how do you read a molecule's mind? Let's dive in. And this really is the big question, right? With millions and millions of organic compounds out there, how on earth do we predict what they do? Think about it like a library with millions of books, but no titles, no genres, no system at all. It would be total chaos. You'd never find what you're looking for. It just seems impossible.
But here's the thing, chemists have this really elegant solution. They don't try to memorize every single molecule. That would be insane. Instead, they look for these small recurring features that give each molecule its own unique character, its chemical personality. And this idea of looking for personality traits, it's not just some clever trick. It's actually the fundamental organizing principle that brings a ton of order to the seeming chaos of organic chemistry.
Think about it this way. Instead of trying to memorize an entire encyclopedia, you just learn the alphabet. Well, these small, recurring parts of molecules, they're basically the letters of chemistry. Once you understand them, you can start to read the language of pretty much any molecule you come across. And that brings us right to the star of the show today. These molecular personality traits, they have a formal name. We call them functional groups.
Okay, so here's the crucial idea. A functional group is just a specific arrangement of atoms that always acts in a predictable way, almost like its own little self-contained unit. It literally doesn't matter if it's attached to a tiny molecule or a gigantic one. Its core identity and its behavior are going to stay the same.
And this right here, this is its superpower, for real. If you spot a specific functional group, you can systematically predict how that molecule is going to act in a chemical reaction. And that turns chemistry from a guessing game into a predictive science. It's a total game changer.
This comparison just shows it perfectly. So over on the left, you've got a basic carbon chain, an alkane. It's like a blank slate. It's stable, pretty unreactive. But look over to the right. Just by adding that small cluster of atoms, that functional group, we've given the molecule a personality. Now it has predictable behaviors and a totally distinct chemical character.
So, now that we know what they are, let's actually meet a few of these molecular personalities and see what makes them tick.
Okay, here are just a few common ones. You got the hydroxyl group, just a simple oxygen and hydrogen, and that gives a molecule the mixes with water personality. Then there's the carboxyl group, which makes things acidic, yeah, think vinegar. And the amine group, that one acts as a base. Each one brings a completely different character to whatever molecule it's attached to. Let's just zoom in on that first one, the hydroxyl group. You can totally think of it as the social butterfly of the molecular world. Its defining trait, its whole personality, is its ability to interact really, really strongly with water.
This is that whole dissolves like rule in action. The reason sugar dissolves in your coffee is because sugar molecules are covered in these hydroxyl groups, and so are water molecules. They basically recognize each other, they interact, and bam, the sugar dissolves. It's all thanks to the personality of this one functional group.
So, these personalities, they aren't just for show. They actually form the backbone of how chemists make predictions. In fact, this whole concept is so powerful, it even dictates how molecules get their names.
Yeah, recognizing a functional group is like having a cheat sheet for a molecule. It doesn't just tell you how it'll react, it also gives you the key to its identity. Functional groups are really the foundation for the entire systematic naming system in chemistry.
And that system, it follows a really clear logic. First, you find the main carbon backbone. Then, you identify the most important functional group attached to it. And then, that group determines the suffix of the name. So, a two-carbon chain, ethane, with a hydroxyl group, which makes it an alcohol, becomes ethanol. See? It's a beautiful, logical system. So, why does any of this matter? Well, because by understanding functional groups, chemists can predict how new medicines might work. They can understand why some things mix and others don't. They can create a universal language for naming compounds. And, maybe most importantly, they can design entirely new molecules from scratch. When it comes down to it, what we've really been talking about isn't just a classification system. It's the actual grammar of the language that molecules speak.
And by becoming fluent in this language, chemists go from just observing the world to actively shaping it. This ability to understand and manipulate these functional groups is what lets us design and create everything from life-saving drugs to the advanced materials that build our entire modern world.
Which leaves us with a final thought.
We've learned these functional groups give molecules predictable personalities. So if chemists are basically molecular conversationalists, the big question is, what kind of groundbreaking conversations are they trying to start next? Thanks for tuning in.